All right, this is Honors Algebra 2, and we're doing 8.5 in Algebra 2, solving rational inequalities by calculator. This is the third video in the series. So this is basically the same skill as when we solved rational equations in a calculator. We make the right-hand side of the inequality 0 and put the left-hand side into the calculator. We then use second calc 0 to determine the roots of the expression, and use our eyeballs to determine which intervals satisfy the inequality that we're given, or the one that we put into the calculator, rather. So recall that greater than 0 means above the x-axis, and less than 0 means below the x-axis. Recall that equal to means you put a bracket around whatever that root is, it's included, and not equal to means parentheses. So that's basically the gist. Let's go ahead and do this thing. So we're going to do the same 4 problems we already did. We're just going to do them in a calculator. So what I'm going to put in my calculator here is in my y1, I'm going to put in x over the quantity 2x minus 1, right? So I'm going to make this x over 2x minus 1 minus a 1 is less than 0, and I'm looking for when this thing is 0 or negative, right? That's what I'm looking for with my eyeballs. So when I go to my y1, I have an x divided by, in parentheses, 2x minus 1, close the parentheses, all minus a 1, right? And I'm going to go ahead and zoom 6 for now. And there's my graph. And I want when this thing is physically negative. Well, you can see that it's physically negative all the way over here, right? And I look up here and I see that there seems to be a root somewhere in here. So we're going to go ahead and do second calc 0, right? And all right, so we want to be above the axis, hit enter, cross below the axis, enter, and there's our answer. Okay, so let's grab this for a sec as a screenshot so I can draw for you what we're talking about here. So now I look at this, right? I look at this and I see that the answer I want is this entire window, right? I want this entire window, and I seem to want this window. So the second window, and let's actually color code that for a sec. So this second window is pretty easy. This second window, right, is from 1, which is the 0 I just found. So from 1 to infinity, and it's a bracket, right, because it's equal to 0. But then there's this interesting thing that happens here. The problem is I really need to know where this happens. Like, where is the vertical asymptote? So the other window, the window I have in green, is basically from negative infinity to whatever that vertical asymptote is. And for that, it's easier to use my brain, not the calculator. It's easier to say, wait a second, the vertical asymptote is when the denominator is equal to 0, that's when x is a half. So the combination of my brain, right, my brain tells me this part, and the calculator shows me the other part. So when I put those together, my answer is negative infinity to the vertical asymptote, which cannot be included because it's a vertical asymptote, and 1 to infinity, which was the 0 I found using my calculator. And if we go back up, that's the same one as example 3. So let's see if we can go back up for a sec to example 3, which I think is that one. We'll find out. Hey, there we go. Yep, sure enough, negative infinity to 1/2 with a parenthesis, and then a 1 to an infinity with a bracket. All right, so there we have it. All right, so let's go on to the next one. Same idea. What I'm going to do is I'm going to move that 3 over. Right, so I'm going to subtract the 3, and I want when this thing is less than 0, so I'm looking for when this thing is negative. This is what I'm going to put in as my y1, right? So I go to my y equals, I'm going to put in parentheses x minus 1 divided by, in parentheses, x plus 2, close the parentheses, all minus a 3, and then I'm going to zoom 6, but it's already zoomed 6. So there's my graph, okay? So here's the idea. Before I even bother to second calc 0, right, let's drag my graph over here and look at what intervals we're talking about, okay? The intervals that we're talking about here, I want when this thing is negative, seem to be here, right? So this interval, so the answer is going to be negative infinity to whatever that 0 is with a bracket, and also this interval, right? That's when this thing is below 0. So also parentheses, whatever the vertical asymptote is to infinity, right? Those are the intervals I'm talking about. The only interval I don't want is this one that's above the x-axis, right? So I'm going to use my calculator to second calc 0 to find this, right? Second calc 0. And I'm going to use my brain to find the vertical asymptote. I'm going to say, hey, wait a second, this denominator equals 0 would be x plus 2 is 0. Hey, that's x equals negative 2. So that's a negative 2. Right, I can spot that, and you could verify it on a calculator by hitting trace, but you're going to see that it's negative 2. So let's do second calc 0, right, and I'm going to go over because I see that the 0 is somewhere over there. So I need to go left of the 0, hit enter. Now I need to cross the axis, which means the y's change sign, enter, and I get negative 3.5. So I use my calculator to get that this is a negative 3.5. So here we go, negative 3.5. And if you want to check, you can actually trace to see that your vertical asymptote is negative 2, right? You can trace and hit negative 2 and see that, sure enough, that's your vertical asymptote, right? So that's my answer, right? And you can see this is the same problem we used in P3. So if we go back to P3 for a sec, which should be here, you'll see that we get the same answer, right? And notice, sorry, skipping down a little farther. There we go. Notice that this is a parenthesis, not a bracket, because there's no equal to here, right? So it's actually open there, if that helps, right? So I want this interval here with an open circle. All right, so moving on. So now this was the really, really ugly one, right? So this was so ugly. Example 4 was super ugly. And we're going to go ahead and do it. So this was super ugly by hand. We're going to go ahead and do it on a calculator, right? So I'm going to move this over. So I'm going to get x minus 2 divided by, in parentheses, 2 times the x minus 3, right? Minus the x, and then in parentheses, divided by the x plus 3. And that's going to be greater than 0. So this is going to be my y1. I want to find when it is strictly positive. So let's go ahead and go to my y1. So we have an x minus 2 in parentheses divided by, in parentheses, 2 parentheses x minus 3. Close those parentheses, both of them, right? Minus an x divided by, in parentheses, an x plus 3. Close the parentheses. Double check that everything's right. Okay, and we're going to go ahead and hit graph. All right. We're going to go ahead and hit graph. Okay, sorry, picking back up. I dragged a screenshot of the graph over here. All right, so remember, this is our y1, and we're looking for when this thing is strictly positive. So the answers that we want are this window, right, and this window. And you can see that somewhere in here this thing crosses the axis, because you can see that line is below there. So essentially we want whatever these two windows are. So we really need to find this 0 and this 0. And we also have to be aware of what the two vertical asymptotes are, right? So this vertical asymptote, if you look at your denominators, one of these vertical asymptotes is x equals negative 3, right? Because that would make x plus 3 equal to 0, right? And the other one is definitely x equals 3, because that would make this denominator equal to 0. So the other one is x equals 3 as a vertical asymptote. So essentially the intervals I'm looking at are from this vertical asymptote at negative 3 to whatever this mystery 0 is, right? And from this vertical asymptote at 3 to whatever this mystery 0 is, right? So my answer is going to be negative 3, not included because it's a vertical asymptote, right? To whatever that a is, right? The thing I just labeled as a, right? And also 3 to whatever that thing that I just labeled as b is. And then my job's going to be to use the calculator to find those two values. So let's do second calc. We want 0, right? And so I make sure, see how my y values are above the axis, and I look for when they cross. There they cross, so I want to be a couple clicks to the left, cross the axis, and then hit enter, and the answer is 1. So A is apparently a 1, right? This happens at a 1, right? And then I'm going to do second calc 0 again. And I'm going to work my way over, jump back. All right, so see how my y values are positive. And then they cross the axis at some point. There we go. Cross the axis, enter, enter. And there we go. And the answer is 6, right? So this apparently is a 6. So that's my window for when this graph is positive, right? So if we go back up and look at example 4, which was the one that was kind of crazy. Let's see. Should have been this guy right here. If we go back up and look at example 4, sure enough, negative 3 to 1 and 3 to 6, and that's the exact same answer we got by using the calculator, right? So same interval. You can see that it's a lot less work if you have a calculator. Anyway, so let's go ahead and do the last one. P6 is the same as P4, right? So if we were going to put this in a calculator, we're going to do x plus 1 over x minus 1 minus an x over an x minus 1, right? So this will be my y1. And I'm looking for when this thing is less than 0, which means strictly negative, right? So I go to my graph. Sorry, I didn't mean my second. I go to my y equals. I'm going to do in parentheses x plus 1, close the parentheses, divided by, in parentheses, x minus 1. Remember, even though you can simplify this, if you're using a calculator, there's an argument for using the exact version that's presented to you. with as little simplification as possible, because the more you simplify, the more likely you make a simple error. So x plus 1 over an x minus 1, both sets are in parentheses, minus an x over the quantity x minus 1 in parentheses. So we're going to go ahead and graph. And if we take a quick screenshot of this graph, right, we have to know in our brains what answer we're looking for, right? So your calculator is never going to replace your brain, right? We're looking for when this thing is negative, right? Well, that seems to be down here, right? That seems to be down here. And then maybe that's it, because it looks like this doesn't cross. I think that it's probably just this window, right? I don't think you're going to have to second calc 0. It looks like it doesn't cross. So, so you actually don't necessarily need the calculator. Really, it just turns out to be before the vertical asymptote. So, so my answer in this case is from negative infinity to the vertical asymptote, which I can see happens at 1, right? And that's it. And if you're not sure if there are zeros, you could certainly like trace to see if it looks like the graph is approaching 0, but usually the hint that this thing is crossing the axis is that you would see something down here or something up here, and you just don't. You don't see any hint of anything. It doesn't seem to be crossing the axis, and you can confirm that if you look at our original answer to P4, that it turns out that when we did P4, the only thing that mattered was the vertical asymptote. As you can see here in P4, there are no zeros for this function because the top is a 1, and 1 can't equal 0. So that's it. And that's how you do rational inequalities on a calculator.